I start with a week-long IR loop, please? This will be our weather discussion for the first day of meteorological spring. It sure feels like spring outside, and it will continue to feel like spring. Here's a look at the week-long loop of infrared temperatures. I'll wait for this to restart here. There were many things that happened this week, so this is hard to pare it all down in a good way. But I'll draw your attention very quickly to the very start of this. Here's our snow last Friday. Very short-lived. I don't even know if we got exactly an inch. It seemed like less. That was the only precip we've had in 2 or 3 weeks. So that's something that's interesting at the very start, and then it just quickly dissipates. I'll let it run once more. We can see that here. And then as you can see, there's many things to talk about after that. So again, right there is our snowfall. Very short-lived. Then, you see it dissipates. We get into sunny conditions. It warms nicely into the 50s and 60s. And then here's what's looming for us, the cold air outbreak. You can kind of see it as it moves into western Canada and begins to trek southward into the United States. It makes it into northern parts of North Dakota, Minnesota, Wisconsin, Michigan, but then it erodes quickly and we're back into this 50s and 60s. But I'll highlight that development because that was our main weather maker this week, was this lobe of cold air and then a developing cyclone that originates from this subtropical jet. You can see it here. I'll focus on that pretty significantly here, but then you can see as it continues to move, it becomes a decent looking cyclone in the IR, stretching all the way from northern Canada, down to Bermuda. At the very end of this, which I'll let it play again, we'll see portions of Canada right now have negative 50 degree Fahrenheit wind chills, and it's blizzarding. Meanwhile, we're sitting in close to 50 to 60 sunshine. It's pretty remarkable. You see it. So it develops. You can see it pull the cold air down, and here's you have your 50 degree, below 50 degrees wind chills, and then blizzards. Now to the main event here. Could we go to February 27th at 18 UTC, please? Perfect. So you'll see here's our system as it's moving through. Could you toggle just back and forth through this time, please? I want you to focus on Iowa into Kansas. You can actually make out the cold front. You see it right there. In the infrared temperature, so this is strong enough to be picked up from space. The difference in the temperature across this front, darker colors are your warmer, lighter grays are your colder temperatures, and you can see it, if you go back a little bit, you can see it, especially in southwestern Kansas, produces clouds as it moves through. The rest of it was kind of shielded by cloud cover as it moved through the southeast and then even our region, unfortunately, but this is where you had your maximum temperature drops that I could find. Places in southwestern Kansas had 68 degree Fahrenheit temperature drops. One station in here went from 87 to 19 degrees. So imagine being like an animal or something that has no idea what is going on. And it's 87 one day and then it's 19 the next morning. I mean, I don't even know if you can fathom that, but you can definitely see it as it moves through portions of Kansas, Missouri, and then into Iowa. I'd be remiss to mention that it did force the development and strengthen a fire in Texas, which we'll see on satellite. In 2 days became the largest fire in Texas history. Wow. And we'll see the burn scar in the visible satellite loop, which is remarkable. It did claim a life and burned through an entire town. And so this was going on at the same time. If we just go a little step
Can we stop
forward.
just for a second?
Yeah.
Another thing, Patrick, about this, you're pointing out the cold front. It's really interesting and excellent observation. It also suggests it's fairly shallowly sloped,
yes,
because the clouds don't show up for hundreds of kilometers to the west.
That's right.
And I wonder if you could almost guess what the slope is and then see how it compares to the passage through us. I wonder if there's any reasonable coincidence between that, because one of the things that we were looking at just before everybody came in was there have been other similarly, 24-hour temperature changes with much sharper edges.
Right.
And this one was kind of prolonged, but systematically the same slope. I wonder if that's part of the characteristic of this thing.
I could believe that, because I wasn't blown away by the temperature drops, but the overall 24 hours.
Yeah. Because the Oklahoma mesonet
Yeah.
can capture some dramatic drops, and it didn't do that much
Right.
this time.
Right.
So that's interesting.
Yeah, it's a good observation, definitely. And the same cloud feature you can see right here. Here's you have your Illinois into Michigan severe weather, 11 tornadoes. Remember, this is still February, and it's 87 in Kansas while there's tornadoes in Illinois, and then a fire to its south. So everything happening, and then if you keep going here, you can see the cold air. There was a blizzard with this as well that I didn't focus on, into North Dakota and Minnesota, upwards of a foot of snow, where, 2 states over, there's tornadoes and it's 80 degrees. So this was pretty remarkable event. And then in its wake, if we just press start again, please, we can see the very end, you can see the cold air coming over the open lakes, no ice cover to deal with, and so you have snow, lake effect snow, towards the very end. Michigan and New York had feet of snow.
That's
from
rare
this.
in February, because
Yeah.
usually the lakes are
Usually
frozen,
frozen.
especially Lake Erie in Ontario. That's
Yep.
really rare.
Yeah.
Boy, oh boy.
So, and then you have another system developing to the south, and we're forecast to be 70 degrees 2 days. So, just wild weather happening with this loop, and then going forward the next couple of days. And if we let it start again here, please.
So you kind of think, among the regional signals that could change as the climate warms, maybe one of the most impressive ones might be the seasonal lake effect snowing.
Could be,
Because
yeah.
maybe places like Buffalo, Rochester will have a 4-month period of lake effect snow threat. It's usually ended by early or late December.
Right.
Not maybe in a warmer climate.
Right.
Wow.
I know that the New York State Department of Transportation is already thinking about that.
Is that right?
Yeah,
How
I could
interesting.
believe that.
yeah.
Interesting.
Yeah, how many more 8 feet of snow in 2 days are there going to be?
Yeah,
It's probably going to be,
right.
every month now you get one of these events, and
Wow, that's so
Yeah.
interesting.
More salt farms. in-
Yeah, right.
Yeah.
right,
And is there anything we can do to make them more attractive?
right. So, wacky week of weather,
Wow.
for sure. I believe that's all I wanted to touch on. Oh, and then there's something brewing in the western United States that we'll see on the satellite, the visible satellite for current as well. So we could go to our climate plots of the temperature, please. I'll show you just how, I don't need to, tell you how abnormal it was to be 60 and 70 in February, but we'll see how abnormal it is for this part of the country from the climate perspective here. Look at that. 70 degrees February, that's like, May,
Wow.
early May. That's how abnormal that is, and if you can imagine, we're gonna have another one of these,
Yeah.
2 days from now.
Right.
I was trying to count the amount of days that didn't have a high temperature above normal, maybe like 10 out of, 3 months. And some of these departures, we have full periods of days that are above the average max temperature.
Yeah.
You can see our drop from 70 degrees to 11 also in this. That was the second highest temperature drop in 24 hours in Madison that we experienced from this event. And you can see the day build up of 60s, close to 70s, 70, and then we're quickly recovering from this cold air outbreak, which is kind of funny to call it because it's just average temperatures, you'll notice. It's just been so warm that temperatures in the 30s feel, like frigid winter, mid-January temperatures. But if you can imagine, we had below 0 temperatures a couple months ago. It's kind of hard to realize that when it's 70 degrees multiple times in a month. So,
Just that cold outbreak, I never saw it on this chart. That was a really singular event.
Uh-huh.
These other things are exaggerations of a trend.
Right.
But that was absolutely all by itself.
that's right. Yeah, you can almost make out the trend here.
Yeah.
Where you have to shift this average temperature earlier in the season. So
Yeah.
maybe we're trying to see the start of a trend or something like that. And then if we could go to our
That's interesting.
snowfall as well. our sad snowfall. So with, multiple days of 70, I could see this plateauing, and we're
Yeah.
20 degrees below what we should be for the normal day. We're about 32 inches on the season, and we had a brief period we were above normal when we had those 2 snowfall events in a row, but I don't foresee us getting more than a foot freak April snowstorm, and then that's it. So we're likely going to finish below normal as snowfall, and then if we could go to our precip as well.
And that's saying something with the snowboard and the problems at MSN.
Yeah.
Because anytime it snows, it's an inch.
It's exaggerated.
And it's always exaggerated.
Yeah.
This testifies to how few snow events we've had, really
Yep.
is what it comes down to in my mind.
That's right. I would say we had one,
Yeah.
November, December, another one late December, 1, 2 back to back, and that's it.
That's it. That
So
is
4
it.
total events, meaningful events, yeah. And then our precip, this will be something to watch. We haven't gotten a lot of precip the past couple of days. We're slowly beginning to develop drought-like conditions, so that's something also to watch. As we go forward, how far do we keep below this average cumulative precip line? It's beginning to be reminiscent of what happened last year, where we started to develop a drought in the spring and then it continued in the summer months as well.
In a companion graph, it'd be really interesting if the climate office would do it, would be a groundwater drought.
Yeah, that's
Because
right.
we had no snow cover. So presumably the groundwater is way lower than normal.
Yep.
Because even if you don't have much precipitation, if you got snow on top, you don't lose that much water in the ground.
That's right.
So I bet it's worse than this.
I do, I know a graph. Could we go to the drought page, please?
You know all kinds of stuff. That's why I brought it up, because I figured you probably already know where to go.
Yeah, I know exactly what we're gonna say. Oh, yeah, that's perfect. And then we could go to current conditions. And there's,
Even those the drop down numbers.
where is that listed? Yeah, maybe. And then if you click this one, it'll go away. No, it's not this one.
Soil moisture is down the bottom.
Oh, there's
Soil
soil
moisture.
moisture.
Yeah.
Let's see what that looks like.
No, this one's not.
Oh, wow, interesting.
Let's go.
That
Oh,
just-
here we go.
you
Here we
don't
go.
know it. Okay.
Here, global soil moisture
yeah.
anomaly. You can see, yeah, we're beginning to develop a deficit in soil moisture.
Yeah.
Especially into Iowa, there's a current drought ongoing, and they've had about the same snowfall we have, so that's exaggerated as well.
So that's like a shadow drop, in my opinion.
Yeah.
Because, but I don't know, I mean, I should say my opinion, I'm glad I did, because I don't have any knowledge about it, but it seems to me like it's a shadow drought. When you start plowing the ground and there's no groundwater,
Right.
and you have no precipitation, you're in double trouble.
That's right.
It seems to me.
So this will probably, yeah, as planting starts to begin, I could see this getting way worse very quickly.
I wonder if this influences futures right now for corn and soybeans. It'd
Could
be
be.
interesting to start paying attention to that, you know?
Yeah. Especially,
I wonder.
here's your corn
It
crops,
does?
yeah.
There's somebody I follow that is like a futures trader.
Yeah.
But this is what they report, is soil moisture and how that's gonna impact.
Oh, interesting.
Yeah.
Wow.
Interesting, future career path. maybe.
Absolutely. it
And you
is
could
for
see-
people in this room.
It's also a big bullseye where you've had your atmospheric rivers, California too.
And Imperial Valley's above normal, that's good.
Yeah, that's right.
For all of us who like fruits and vegetables.
Yeah, certain kind of fruit. Okay, and then we go to, I think, our visible satellite current, please. Oh, and that same day that we had all the weather, 132 warm records were set on May.
Wow.
Some all-time February temperatures. I know in our state, we had an all-time February high temperature. Here's a look at the current satellite loop. So things point out. Here's that big system, kind of make out. It's hard to see with the clouds and the snow cover, but it's situated to the east of Hudson Bay, and it extends all the way down into the tropics. You can see the big cold front feature. That's what moved through our region. Lake effects, sea effect, snow in its wake. This is all from cold air advection. You can make out, here's one snow band north of Syracuse from the lake effect snow. You can also, if you believe me, there's the Tug Hill Plateau. You can kind of see it carved out in like a triangle shape. Everywhere that's abnormally white in lee of the lakes, is lake effect snow from that cold air outbreak. You see this black dot, which we can zoom in. Maybe we'll zoom in. Could we go to the CONUS loop, please? This will, see, I'm not just saying if you can believe me. Perfect.
Oh, yeah.
There's your fire. So you can see it originated in one town and was completely moving eastward, and then the cold front came through and shifted it southward.
Wow.
But you can see it from space, which is kind of remarkable. I believe it's still burning to this day, too. And then if we could zoom out and maybe zoom in.
I mean, our candidates should have been at the Oklahoma, Texas border yesterday.
Oh,
This is the shortwave infrared from February 27th, so that's the
Oh,
day
yeah,
the front
yep.
came by.
Yep.
You can actually see the front sort of go by, and wow, I mean, it's a,
wow. So it's being picked up from space, how big it was.
Wow.
yeah, the yellows and the blacks are really hot pixels.
Yeah, it looks like a discrete propagation to the northeast there into Oklahoma, or, you know, that last piece up in the
Yep.
north.
Yep.
Yeah.
First it's a line, and then boom, it jumps northeastward.
My uncle lives in Lawton, which is right here, and he always says, they always put up fire warnings and nobody listens. Even though they should, because, you know, one single spark and you have the largest fire in Texas history.
And this is grasslands too, pretty
Yep.
much, right?
Yeah.
Yep.
So
A
it's bone
million
dry.
acres, I think I heard.
Yeah.
Over a million acres, that's
Wow.
5% contained.
And went through an entire town, which is very sad. Yeah.
You mean Texas Public Services were not sufficient to take care of it? That's a surprise.
No comment. Can we zoom out and maybe look at the lake effect snow in New York, please? Here's that band that I was pointing out. And you
Oh,
can see
yeah.
the Tug Hill Plateau
And the valley.
in the valley, yep. So,
This would be a perfect time for this one.
oh yeah, yep. Yeah, you can clearly make out what's snow on the ground, all the green, and then the clouds that are moving.
All right, Pete, you're convincing me.
And we're just beginning to get into higher clouds. If we stay in the sun, we might get into the 50s.
Yeah.
It's currently in the 40s, but places to our south are right now in the 30s and 40s. So hopefully we stay in the sun, we can get a little more warmth as well. Then can we go to the 500 millibar super peak, please? Look at current conditions in the mid-troposphere here. So you'll see two main features here. Here's your low pressure that brought us the cold front that moved through our region. You can see it on the satellite. Very well stacked and very strong. And then another feature off the California coast, which looks to be poised to bring some interesting weather to definitely California and Oregon and the mountains, and then maybe even potentially into our region. But we're sort of in this no man's land where we have two big features, and we're in a slight ridge in the middle. There's a cyclone to our south. We can make out a shortwave trough, upper level divergence, right where you would expect, and then that cloud cover beginning to encroach on our region. But we should largely have, you know, clear conditions depending on where that cyclone is moving. Very little temperature advection at all throughout the entire United States. Coldest air definitely is with this cyclone moving onto the northwest, and then it's largely, you know, roughly the same temperature throughout much of the United States as well.
I don't know how many times I've seen minus 43 or colder in a
Right.
patch that size off the Pacific coast. It's incredible.
Right.
And there's a-
Normally that should be, you know.
Yeah, archipelago territory, and it's got a conglomeration of convective elements. They started out as a popcorn cumulus yesterday, and they've totally turned into a whole bunch of, I guess you call them NCSs over the ocean, and it's going to be one after another in Portland, Seattle, and Northern California over the next several days, because that's going to take a while to dislodge.
Right.
Just incredible.
Right.
Plus, there's orographic flow of the Southern Cascades.
Mhm. Funny you should mention that. Could we go to weather.gov, and I'll end on this, because this is not something you see every day. We could click on.
Whoa, just where you want it, just exactly where you want it.
And can we, is there a way to enlarge this image, maybe? Oh, perfect. So here's snowfall forecast. All of these regions in the purples, 100 plus inches of snow. And this is over like through Sunday. And some of these places are having winds of 150 to 200 miles an hour. You're sitting in the low-level jet when you're on top of a mountain. So if you can only imagine being on a ski hill, you know, you wouldn't be, because you wouldn't make it out, but you know, 120 inches of snow in 2 days. It's pretty remarkable for, you know, one mountain, but then you have the entire portion of California highlighted by this storm, so.
Do I have to hear this?
Right?
No, this is great news though, because look at, just to the west is the Imperial Valley.
Yep.
There's water in the bank right there.
That's right.
And that's great news.
That's right. Yeah. Yeah, so places like Quincy are getting our season snowfall in 2 days. We're gonna be 70 degrees, which you can't complain
Yeah.
too much, but, yeah.
That's incredible.
So anything else anyone wants to see or talk about? Okay, perfect.
All right, thanks, Patrick. Excellent as always.
Thanks, Patrick.
I don't know, I mean, we've had some really good people come through here with this, you know, intense interest in all the various websites and resources. I don't know if anybody rivals Patrick. He just seems to know where to go right away everywhere. Minus 43, we have to look at the satellite, Pacific infrared, the old style one. If we can. It's so awesome today. No color. I'd rather take the color out, but you can see the same things. But let's see if we can move it out the color. Yeah, we can do the color. It's okay. I don't want to list it this time. We got it. But you can see these elements are large convective elements. Oh, what happened to it? Okay, thanks, Pete. Large, and notice there's little swirls inside there you don't see in the 500 millibar chart. So I think what's going on is this air is so cold, the stability, in fact, we'll do this again when we go back to 500 millibars. I'm presuming the surface temperature of the water is about 10 degrees C. So then you're minus 43, it's 53 degrees C difference between sea level and whatever the height is. We'll check in a minute, so we'll do that in just a second. In fact, we better do it now. Can we go back to 500 millibar map and keep this ready? So minus 43, and the height is about let's say 5,100 meters. That's the lowest, it's 5,100 maybe in the middle of this cold pool. So 5,100 meters, 5.1 kilometers, 53 degrees difference, assuming 10 degrees surface temperature. Let's even make it really cold, 8 degrees. That's a 10 degree per kilometer lapse rate. And what threshold does that pass? It's dry, unstable, it's absolutely unstable. So if we go back to the satellite, that's why these things are just erupting without any restraint at all, and they're conglomerating. So you start out with smaller elements outside on the periphery of the coldest air. Inside, they can't help but have multiple elements to each of them. And once they do that and congregate a little bit, the column stretching's concentrated, and you get these little swirls. And there's more than one. That's the most dramatic one, but there's a few more in there embedded inside. So this is a really great example of mesoscale organization based purely on instability. That's what it is in this case. Not really dynamics, because this is a broad upper trough, as Patrick just showed us. There's no particular region where you ought to have strong ascent. It's just the ascent is organized by the organization of these cells, which in turn is organized by the space between them in the really extraordinary instability. So it's really, really nice. I have not seen such big elements, and if I had to make a guess, I would have said it's about minus 40, just by looking at it, and it's even better than that. So really dramatic. And these elements will be swirling on shore until this cold air mass is kind of dislodged or the whole trough has moved off to the east, and that's going to take some time. So not only is there already some continuous threat of precipitation on the coast, but then it's going to start to become periodic and intense during those periods of precipitation. And at high elevation, it's going to be snow. So a lawn chair somewhere up here near the Donner Pass would be a great place to be all weekend long with sufficient warm clothes, something to eat. Really, that would be awesome. So it's not going to happen for me. Now, that's all I'll say about this. I have to tell you, we're at the end of our cold season. So Pete, can we go to my machine? I have a couple things I want to show you. I think this will be the first one. Yeah. We'll page through this. 3 of these. We'll do them one at a time. This is the time series for the cold pool at 850 for this last December 1 through February 28th. Remember, about 10 days ago, we were down here, and the running situation from the record year, 2014-15, was way up here. And so I thought if we could continue that, we might have a chance. But we got colder and almost all the way through the end of the year. We were number 2 through February 27th, and then there was just enough cold air on the 28th around the hemisphere to bump us fractionally above the number 2 year, which was 2013-14. So it was back-to-back record years. Now, we ended up 3rd, so Ben, sorry. long wait for the answer, but we ended up third. No shame in that. We had 4 days on this calendar, in this 90-day stretch, where we had the all-time minimum. That's exceptional. And we ended up third, so we're in the 96th percentile or something. If you came home in 8th grade with a standardized test, showed your parents 96th percentile, you'd be pretty happy about that. So that's where we are. And there's a little bit more to say about this. I have a couple more things I'll show you. Here's the ranked years. And the year is the December of the beginning of that season, December, January, February, 14, 15, and so on. So we ended up right here, about 3 million square kilometers shy of base. So we almost made it. And somehow it got cold over the Louisiana Purchase or equivalent area on the last day of the tally, and that was sufficient to throw us off. But one last thing on this. Here's the seasonal time series from 1948-49 to the last year, at just -5. So unfortunately, it's kind of a little shrunk, because I have 5 other thresholds I track up to, and I only wanted to show you this one. We used to average, every one of these dots is a 90-day average, December 1 through February 28th of that particular cold season. And so, you know, at the beginning of the season, it's probably not as high, and at the end, it's a little higher, but this is the average for the whole 90 days for each of these years. And it's not uniform, it goes up and down, of course. The longest such streak of down or up is 3 straight years. That's weird. And this is now 76 years long, and you never get a streak longer than 3 years. Very, very interesting. But nonetheless, we're now hovering around an average of about 65 million square kilometers, or the annual average. In 1948, it was 7 million. So it's gone down 5 over 70, which is, I don't know, 4.5%, 4.8% systematically. The red line is the trend line, significant at the 99.9% level. So this is a global warming signal. There's just no two ways about it. It's just getting warmer. And when you average over the whole northern hemisphere, over the whole winter time, we keep getting smaller and smaller areas with some interannual variability. So that is of interest to me. We had our second earliest ever ice-free Lake Mendota, February 28th, Wednesday. The prior record was February 27th of 98. And I told my kids on that day, they were 5 and 2 at the time, I said, let's go throw some rocks in the lake. You'll never do it again in your lifetime. Under the illusion that global warming, though a threat, was at the Heisman level. It was way out here. It wasn't that close. And not true. It's right in our face now. And so it's hitting right now. It's going to keep getting worse. And so second time you could throw stones in an unfrozen Lake Mendota in February has just happened. And it probably won't be the last. There won't be a 28-year gap between the next one, I don't think, or 25, whatever it is. It'll probably be more like 5 years or 6 years. So the return time is getting smaller and smaller. So that's the word on the cold pool this year. Oh, one last thing. Earlier this week, I wrote to Jason Samenow, who runs the Capital Weather Gang at the Washington Post, and I said, Jay, I got maybe the second warmest year ever. And he's kind of been interested in this since I first published this work like 10 years ago. And he said, oh, I'll get somebody on it. And the guy calls me the next day. We talked about it. And I stuck with my story that it was probably going to be the second warmest year. And so, to my horror yesterday, when I found out it was the third warmest year, I thought to myself, somebody asked me, well, what do you think about retracting your article? I said, no, I'm not going to do that. I'm going to leave it at second in the Washington Post. Everybody lies in Washington. Why shouldn't I be included? So that's the way I ended on that. So that's the way we're going for the cold pool. So let's go back to our forecast. And it'll just be brief, because I didn't have any time to prepare it. I'm sorry, I did not. But I think what we want to see is, it looks to me like we have, as Patrick was alluding to, we have another warm-up coming, so we want to talk about that. But it's not followed this time by the dramatic cool down. So I think the coming week won't be a roller coaster like last week. It occurs to me that it might be interesting to look not only at the biggest 24-hour drop, but maybe the largest integrated swing over 72 hours or something in the time series. That could be interesting too. This might be a singular event in that regard, because we warm up so dramatically in the coming couple of days. So let's see. Let's go to the 12-hour forecast at 8:50, made last night, so this will be valid tonight at 6 p.m. You can already see some of the pieces of the puzzle with the deep trough off the west coast and strong flow at latitudes of about, northern or central California. That sets us up for really strong, and it's a broad scale trough with a little bit of that kind of weak ridge over here at 12Z. There's going to be strong across mountain flow, and you can see that already manifesting as a lee-side trough in the high plains. Maybe there's a bias toward the southern plains, but it's a pretty strong feature in the high plains as well. Geopotential height trough, coincident with the temperature maxima. If you can see these arrows, you don't even need to see them. You know the geostrophic flow is going to go from here in eastern Colorado towards Wisconsin. So there's strong warm advection occurring overnight tonight in the Central Plains, and we are certainly the beneficiaries of that. Probably this signal might have a little bit of a diminution when you get to 12Z, but I think the broad signal will look the same. So let's take 12 hours ahead from this peak for tomorrow morning. Yeah, the maximum temperature is a little bit reduced because it's 7 a.m. in the morning. However, the advection stays strong and it's progressed to the east, so we're already warmer, even by the whole structure moving east. But there's continued warm advection when we wake up tomorrow morning with an already warmer temperature. And I presume we can look at the 500 millibar flow quickly just to see if the cross mountain flow persists, but I'm pretty sure that it does. Let's do that at 24 hours. It's pretty decent. It's going to get better, but it's pretty decent if you imagine that the Rockies are oriented roughly like that. This is just about perpendicular to the high terrain. So subsidence in the lee is maximized now, and missed that something. Here's our lee side warming is really intense. It's exacerbated now by development in southeastern Montana. That's going to help the circulation around this feature. Continued warm advection, particularly strong over eastern Nebraska, eastern Kansas, so they're going to warm up tremendously during the day on Saturday. And we're already in the light greens, which are on the order of 8 to 12 degrees C. What do you add for a kilometer and a half? You add about maybe 8 to be conservative, so we're something like mid to high 50s minimum. Maybe with the sun out, we break 60 on Saturday, but we certainly will on Sunday. So let's go 12 hours ahead one more time. And by then, the entire complex, including the development, which has moved now from southeastern Montana into central North Dakota, it's weakened perhaps a little bit, but it's still an intense circulation around it. That actually makes Sunday morning the period of strongest warm air advection for us and highest temperatures over this whole sequence. So it's a double whammy. Sunday is going to be really exceptional again. So pretty incredible. And so I think I want to work back from here at 500 millibars to see what is driving some of this development. But this looks like the early part of the week, the late part of the weekend, early part of the week, exceptional warmth. Notice this time, as opposed to Tuesday into Wednesday, no bitterly cold air sitting immediately adjacent to the warm air. We don't have that strong contrast right on our doorstep. It will evolve a little bit to look a little more like that, but we'll take that up in just a second. First, I want to go back to the 500 millibar map, starting at, I think, 24 hours and just watching how that goes forward. So that's where we were. And so you see this sharp vortex structure. I think it's really worth it, Pete. We got to go to tropical or somewhere and get a cross-section like that to do that feature. Maybe we need a different, tropical. The problem is it's tropical. Maybe North America. Maybe we can get a cross section there. I can't remember. Some of them don't allow that. So let's go to the 500 millibar vorticity if we can. There we are, right there. I always forget what it is. And then go to this was 24 hours. So it would be 12Z on Saturday. One more. Yeah, right there. Let's kind of cross section about right like that, perpendicular to that vortex structure.
Shift.
I think it's controlled.
It's controlled. So maybe it won't let us.
It might not let us do this on this. Is there another region that we can cheat on? CONUS is no good. Well, maybe this one. Let's try this one. Yeah, it looks like you can make a cross section. It's okay. We do 500 millibar height. I have an idea how it'll look. Not anomaly, yeah, the actual height. So let's go like right here. And we got to go to 12. Try 12. Doesn't look right. Okay, let's try this. I think this is roughly the angle that we had. Okay, see what that looks like in the PV. Yeah, wow. So that was a good one. That sharp vortex structure that we saw at 500 millibars, this height, here's the narrow vorticity structure, and you can see it in the isotachs, how closely spaced they are together. First of all, 120, 30, 40, 140, 150 knots at 400 millibars, and this is a tongue of high PV that comes all the way down to 800 millibars. And an extraordinary upper front, and a lower stratospheric front. Look at that one, right in there. So that's a remarkable upper front, no barotonicity back in the cold air, and none in the warm air. It's all concentrated right in this front. it presents itself as a potentially important synoptic development mechanism. That's not always the case, depending on geometry. Let's now go back to our regular maps at 500 millibars and see what they look like in the evolution. So we'll go ahead at maybe 6-hour intervals, 24 hours out with what we just looked at. Here's a day later. It looks like things get a little discombobulated at the terminus of this structure, but presumably this whole thing looks the same as what we just saw. A really sharp tropopause trench, tremendously narrow upper front, very intense, but it doesn't have a lot of curvature to it. This is broad curvature. Radius of curvature is probably something on the order of, I don't know, 3,000 kilometers or something. So that's big, and it doesn't produce a lot of vertical motion by itself. Downstream, things get a little bit ruffled. That might be the high resolution and interaction with the mountains. But that we saw results in the strong lee-side warm anomaly. I'm not sure why there's such a strong development over Montana, and I think we saw that most predominantly between 0 and 12Z on Sunday. So let's go to the 12Z on Sunday, 12 hours ahead of that time. That's a little more obvious. This is the one that's tied to the development over North Dakota. So something interesting happens to the upper vortex structure during the weekend that's not immediately apparent to me. How do we go from a fragmented collection of little vortices? Maybe it wouldn't look so fragmented if you smoothed it like you could at a lower resolution, and then turns into some fairly well-organized upper vortex over northeastern Wyoming, downstream of which in northern or central North Dakota you get a pretty decent cyclone at sea level. And nonetheless, there's still strong cross-mountain flow in the middle part of the continental United States. That, I think, enhances the warm anomaly over Iowa, parts of Nebraska, and South Dakota, and the strong but persistent southwesterly flow throughout the whole lower troposphere really ushers it into us. So Sunday is going to be exceptionally warm. And then one wonders, since the cold air really at 850 resided well to the northwest, this is a deep trough, but somehow the cold air is kind of orphaned over here. It's not particularly cold over the Intermountain West. What will happen next? And that's what we'll look at now. We've got a couple of minutes to do that. So let's go to 850 at probably 60 hours after the next. So there's our cyclone revving up kind of nicely. It's trying to drag the really cold air in. The best it can do is drag in this purpley cold air, and it's got a little tongue of that back in there. Here we are in Wisconsin at 6 p.m. or so on Sunday. 850 millibar front is right on our doorstep. It's probably over us, so we probably had a surface passage with a wind shift. Not much temperature drop yet, though, by the time we get to late Sunday or mid-Sunday evening. And notice this barochronicity doesn't come close to rivaling what we had on Tuesday night into Wednesday. So there'll be a little bit of a temperature drop, but it won't be as dramatic. Let's go a day ahead, so we'll go to Tuesday night. And what happened to our cyclone? Kind of gets sheared off somehow. And we stay in relatively warm air. The cold air has made no progress southeastward. The barochronicity has stayed about as intense. The frontogenetic activity that sometimes accompanies, a change in the circulation encroachment doesn't happen this time. We don't have any tendency at all to make that gradient stronger. Probably it means it's less cloud prone than it would be otherwise, and it takes a long time to cool down. So we're not very much colder on Monday night than we were Sunday night, even with the initial frontal passage on Sunday night. Maybe stalled out over us. Let's go a day ahead. And we're a little bit colder. Here's the edge of the front that we had go through us on Sunday at 850, and it's, down past Chicago into Gary, Indiana area by then. We're a little bit colder, but there's absolutely nothing left of that little perturbation in the geopotential height. And what is left is elongated along the barochronicity. So along the front, it's not really going to do anything to organize or enhance the barochronicity or advance it further southward. So it looks to me like I could show you the rest of the maps. You can look at them on your own. You're going to find that the rest of the week stays about like this. This is a fairly stationary thermal pattern for us. We have a really dramatic warm-up Saturday and Sunday, and then a very slow cool down from Sunday afternoon into about Wednesday, and after that it hits the wall. It doesn't get any colder, and it might even be unnoticeable, depending on what you do outside, because it won't be windy. So you'll know it's not 65, but you're not going to think it's wintertime either, I don't think, as we get into the middle part of next week. Or early part into the middle part of next week. So that's the way it looks, and you can see the shrinking of the bloody cold air. It's completely gone almost, except for the archipelago in this part of the hemisphere. And that is rather on target as well with the calendar. That's what starts to happen rapidly in early March. So, and it may be exacerbated by things in the lower stratosphere this time, which maybe you can tell us about next week, if you're game. I know you got class right before too, so.
Yeah.
So any comments or questions? Okay, well, thank you, Patrick. Pete, thanks as always for not only driving, but reading my mind. And thank you all for your attention, and we'll see you next week. All right.
The big culvert.
Yeah, it's gone away. Look at that. Complete retreat to the pole.
There's a little bit of generation of it down here at the end. And then somehow
Oh, yeah,
right at-
next rain or something.
That's up in La La Land Road.
Yeah, boy, interesting. Thanks again, Pete.
Yeah, you're welcome, John.
Every area down on our side, up until 2020, it worked.
Yeah,